concept. We'll keep that for tomorrow when I will have more graphical stuff to show you, because some of the concept I'd like to share with you. If we want to go a bit further in detail, we'll need to have a proper proper schematic that I will show you only tomorrow. So today we'll try to see the maximum of things we can, and at the end of the day, you will, and I will know also what, by your input as well, I will know also what is the most important to check. I will enable the video, by the way. Okay, so can I share my, okay, cool. Sharing is enabled. I'm gonna start. Okay, let's go. Well, most of you expressed that they wanted to know a bit about what is HPC. So I think this is the right moment to introduce a bit in the context of this refresher. So I will try to be as much exhaustive as possible. And also, please don't hesitate to know to let me know to the facilitator, and it will take the mic to let me know if you have a question or if something is not clear. I will do my best to be crystal clear, but be aware I'm not a native English speaker indeed. And also some concepts are not always easy to explain. So if I'm a bit more, too much specific, or if something seems unclear to you, please do not hesitate to let me know. We are here to make sure that all of you will understand the basic of what I will say, which is intended to help you to go to the next step when you will go for practicing. So before answering questions about what is how to define IT infrastructure, I'd like just to remind what is a computing cluster, and what makes a computing cluster different of another kind of cluster, and what changed from the beginning of supercomputing, I mean, a few years ago. And so we have still some old style supercomputer running in some places. But just to give you a quick overview and a very short history. So at the beginning, at least if I give you an example I know quite well, about 20 years ago when I started in CGG, I've been hired to support them in the process of migrating from what we called in the past mainframes. I don't know if some of you are very familiar with that. Mainframe was this super big computer, which Bill has been a manufacturer of such hardware, and we are still manufacturing some of them for some customers, for legacy mainly. This has been very popular in the industry, mainly in the banking industry. So we won't talk a lot about it, but just to give you an idea, already 20 years ago, we started to stop with the mainframe approach for supercomputing to use a parallel approach, which means that instead of using a very big hardware with a very big amount of memory and very costly hardware, uh, since the cost is enormous for acquisition and for owning as well. So this was not economically efficient anymore, and not only it was not also responding correctly to the need of scalability and I will say what what we used to a very common expression in the with container and an orchestration, which is called horizontal scaling, which means that the ability to spawn the load to a large amount of different machine rather than to increase compared to vertical scaling, which consists to add some more resources to a given machine. So this has been started, I would say, 15, 20 years ago, with stop to build gigantic machine uh, and switch to cluster to computing cluster approach. So what is an HPC supercomputer? It's basically a set of standard nodes. I would not say chip, but you can say chip compared to what is a monolithic mainframe. But when we say chip, I mean ordinary in the way that it is using standard x86 hardware. So x86 or x86 underscore 64. So basically, it is the same architecture as your own computer, as your own laptop, for instance. They are sharing the same roots, and the same architecture. The difference is the servers that we are using in supercomputing are they are servers, so they are not the same grade as your own PC, but they are still x86 hardware family. So we use a lot of them, and most of them are not specialized. They are only used for computing, for their computing power. Some of them are a bit specialized. They are using GPU, and we are using the GPU power to bring compute power, but we'll come back to that later. Another thing you can find in the cluster, which is, as a reminder, it's an aggregation of a standard servers. You can have specialized nodes. We used to call them nodes, in a cluster. This is a term we are dedicated term for to name compute. And some of them have a special roles, such as login to permit login to the cluster. Some of them can be dedicated to storage, to provide either archiving storage or scratch space, or different. They can have different roles, but generally speaking, you can consider that an HPC infrastructure is made of compute nodes, specialized or not. Some of them embed some GPU, some very powerful graphic cards, which are not used to play video games indeed, but they are used because of their very high density of transistor compared to a generic CPU. But once more, we'll come back a bit later on that. And so you have storage, either for archiving or long-term storage or whatever, normal storage, and you have also high-speed storage, which is often handled by Lustre, which is very common in HPC. But this point will be seen a bit more in detail further. Another thing important is to know that we used to talk about partitions when it comes to cluster. We used to divide it in partitions, and so we can, for instance, say, okay, we segregate our compute power in a few partitions to get a more easy way to isolate the resources, or to dedicate a part of the cluster to some jobs or another part to some other jobs, or do other advanced management of the cluster. This can be done using an orchestrator. The most famous is Slurm, that you will be practicing Slurm with my colleague Benoit during the third part of the training. So that's it for HPC. It was a quick and rough description, but at least it gives you a rough idea before going further to infrastructure. Just before going next, I'd like to know if some of you has any questions regarding my descriptions of what is HPC, or is there something that has been not clear, or something you want to ask?
Any question? None for now.
Okay, if you have any questions, so I will go next. So what is an IT infrastructure? Basically, it must be seen as written as your information system backbone. This backbone is handled by a few pillars that are at the very beginning. I would say the data center. It's not really a pillar, but it's the very basic. I mean, before running any infrastructure, you want to have something to physically host it, and this is a challenge. This is something you want to consider, and I know that the reality is a bit complex, especially for you guys in Africa, especially in regard of of the power consideration. It has almost always been an issue, and I feel it's not going better in some countries I knew, since the demand increase, and the means for producing power are not, I mean, are not evolving as quick as they should, and you have a lot of power outages that are really a challenge for the guys that are managing data center. I can tell you that it's really challenging to deal with that. But hopefully there is a lot of solutions that exist for to circumvent that. Anyway, data center is the first brick, is the very first thing you have to consider when it comes to build an HPC system. And power is the main factor, and cooling is another one, and it's often linked to power, unfortunately. because to bring coolness you need energy, and that's a problem. And the challenge in when it comes to data center and when it comes to infrastructure in general is that you are providing a service and you have to guarantee this delivery. So whatever happen, your business as a, I would say, as an infrastructure administrator, or now there's even a new job that emerged that's raised with the cloud industry, which is called SRE, which stands for Site Reliability Engineer. So it's definitely now it begins even a full-time job. Uh, while in HPC we are a bit relaxed, I would say, compared to some other productions infrastructure. I don't know if you guys can imagine if for some reason one day you just connect to internet and you go to Google and Google say, okay, sorry, we have an issue. You know what I mean? I think no one would understand, and you cannot expect that at some point that oh sorry, I should stop the share, that Google is just not answering. It's something that cannot happen. Well, it can happen, but a lot of people are putting a lot of money on the table and a lot of resources, a lot of efforts for this thing never happen. And in my particular specialty, this is something very important that we want to consider. Uh, what we aim to track especially is what we call the SPOF, the single point of failure. So that's why we aim to eliminate them, to analyze them in a infrastructure and eliminate them. For some of you guys that are already familiar with network, you should know one thing or two about redundancy and availability. So this is for network, but it's already complicated. But when you think about infrastructure as a global level, you have to think that globally. So your power needs to be redundant, your UPS needs to be redundant, your generator as well, and your switch mechanism must be pretty evolved and tested. So that's a challenge for us for people that are responsible or accountable for production sites and so on. But once more, in HPC, well, at least from my experience, I can tell you it's a bit more relaxed than it can be for the guys, for instance, that maintain that host a WhatsApp or YouTube or whatever. So we won't go in detail for now in how we manage that, but this is something we'll come back at some point. You will see a lot of example of redundancy and how we aim to track that. I will come back to presentation.
Can you
Okay,
hear me?
so
Hello?
in the data centers, what we have, we generally we are hosting servers or farms of servers. I don't know if you guys are all familiar with data centers, but I hope so. But if not, I don't have a lot of pictures to show you today, but maybe tomorrow I will come back with something more elaborated. But mainly we have servers and network equipment mainly. Uh, I don't count also storage and so on. I don't include link equipment and so on. This is something separated, but mainly what we want to host are servers with our associated storage and mainly network equipment. Storage indeed. Uh, this is a very important part
Sir,
of the infrastructure.
sir,
System and services.
Camille.
So this is on, I would say, almost on top of a server, and this is very important. This must be chosen carefully,
Camille, please.
and
Question.
services also that you will run, uh,
Who's
daemons, middleware, and whatever.
is
All
actually
your infrastructure services must be carefully selected and maintained and secured.
sorry, Camille.
Not only in terms of access, but I mean secured in terms of service. So you have to, it's your responsibility to find a way to make them redundant.
Sorry, question, please.
Yes.
Hello,
Yeah.
hello. Do you hear me?
Yeah, sure. I can hear you.
Yes. Okay. You talk about redundancy and availability earlier, and
Hmm.
as a part of the IT infrastructure, you didn't mention the UPS, the unit power
I,
supply. Is it considered
I,
as a part of the infrastructure, or it's not part of the infrastructure?
yes, sure, it is. If you consider it globally, yes, it is indeed. Indeed, it is. And I mentioned it, I'm sorry, maybe it didn't heard it, but I mentioned it for sure. I mentioned UPS and generators. Yes, UPS are, I would say, not even an option for sure.
Produce more availability for the system. Sometimes.
I'm sorry. I'm
Hello.
sorry. I'm sorry.
Hello.
Yes, I can hear
Yeah.
you.
To
You
have
say
more availability of the system, I guess.
yes. It's
It's a part of the infrastructure who is really important.
yes. It's I would say it's mandatory. It's one of the first things you want to consider. Really, definitely. Keep in mind that everything comes from the power. So even for a server, just never make any sacrifice on the power on the power supply. This is definitely what will keep your hardware the longest time as possible, and this is definitely what will make the difference. Because your motherboard, modern motherboard are using, I don't want to be too much technical, but they are using power regulator, MOSFET, and whatever. So processor are expecting a very, very, very stable power for sure. And this role is handled by MOSFET embedded on your motherboard. This is a motherboard job, but to help the motherboard to keep healthy and to avoid I mean stressing components and shorting their life, it's obvious that you have to choose carefully your power supply, and for your power supply to stay the longest as possible, you have to choose carefully your power source. Mm. And choosing an UPS is not a small question. If you are interested with
I knew that.
we can discuss. Maybe tomorrow we can keep a slot to talk about different UPS technologies, because you have. I don't want to spend too much time with that, but there is different UPS technology. Maybe you guys, some of you are already familiar with that, but mainly you can differentiate to make very simple. You have two family of UPS. You have the one that are in bypass, that are, I mean, when you are in this case, you are in front of the power network. Okay, so you are directly in front of what your energy provider is providing you. You see what I
Yes.
mean?
Yes. Yes.
Okay. and this is the bypass mode. So in this case, when a power outage comes, you have kind of a relay that switch back to battery, and from the battery you have this this inverter that create from continuous current that create alternative current.
Yes.
Okay, but all inverters are not the same. You
Yes.
have pure sine wave, and you have PWM basic inverters that are not the same quality. And even with a good quality inverter, you have also different family of UPS. You have UPS online, inline, and online interactive. So you want to choose the one that for which you are never in contact with the outside. It means that whatever the power is available or not, it will never trust it. So the first thing it will do, it will start to clean up this power, to convert from alternative to continuous power, okay, and to rebuild the sine power,
Okay, I
okay.
get it.
So you have a pure sine wave on the outside, and you are never in direct contact with the outside network. And
Okay.
it's also a good option for the galvanic insulation. So for a lot of reasons, it's yes, definitely, guys, this is important.
Yeah.
Choosing the
Just
right UPS is important.
yeah.
Choosing the right PDU also.
Okay.
PDU, I don't know if everyone is familiar with PDU,
Do you?
power distribution unit.
Yes. Yes.
This is yeah. You see this big bar. You see if all of you guys are familiar
It will
with
manage the network. Okay.
yeah, with racks, you will see PDU. This is we call them also power bar, but the term is PDU, power distribution unit. Mm? So this is something important also as well. When you are designing a cluster, ask you the question: okay, do I have often servers are very oftenly using redundant power. Okay, so if you are using redundant power, that is fine, but do not create another spot by putting them on the same PDU and powered by the same UPS, powered by the same live wire. See what I mean? So just tackle and track the spot. Spot is your enemy. You want to get rid of the spot. Single point of failure is
Yeah.
is our enemy, guys. I
Single
tell
point
you.
of single point of failure. I get it.
Yeah, you want to track that, and at every this must be your credo. I would say this has been mine for more than 20 years. So I'm a spot hunter. Yeah, and uh, and as for many things, when it comes to redundancy, to error corrections or whatever, you can find that also in networking world, in whatever. You have different ways of achieving different things, and you can treat things at different levels. You have different strategy to do that. But also my goal here my focus is to be very practical oriented. That's why, how to say it, I'm not here to, I would say, wooden chacha, to take an expression. I mean, uh, you want something that you can realize in real life, and that's why me and my colleagues will try to give you the most practical experience, and take in account the fact that you are facing specific context, especially in this regard, power and cooling. Mhm. Okay, so I will follow to next. I think I said everything important in this regard, because mainly just to conclude on that, this is something at the beginning of the project, everyone must be involved and everyone must be concerned, even you as a system administrator. You are not in charge, you are not responsible of the energy providing, but your responsibility is to involve everyone in the chain. You know what I mean? So when the project is still at the stage of design, everyone must be involved, and even the lowest technician must understand not the detail, but the responsibility it has in the chain of this business continuity. So this must be considered from the beginning as much as possible. Okay, let's continue. So we were server, physical, storage. Storage is pretty important. We'll go later. That we'll come back at least twice in storage, one first today and one in further detail tomorrow. Same will go for network, for virtualization, and for system and services. So this is the first layer for you guys today. And network also, it's a very big also item, very important that you don't want to skip during your design, I would say, because since as a lot of things in infrastructure, it's important to design it early in the process, because when it's already staged, it's always a bit complicated. Try to think about a scaffolding, for instance. You mount a scaffold on a big building, and your boss come and say, "Okay, guys, I want you to remove the first level." You will do it, but it's a bit more complicated. Mm. So it's part of the job. You will have at some point to deal with that for sure. We have the case on almost every project. Clients that design something, we say to client, okay, beware, this should be made this way, this way. The client say, okay, no, we're happy with that. We said it, and maybe 3 weeks, 1 month, 2 months, 6 months later, the client come back to you and say, okay, maybe you were right. I have a concrete example at ISOM project, the first supercomputer of the Euro HPC project that I'm achieving currently. The customer didn't see the importance, didn't realize the importance of splitting the management network in out-of-band management and in-band management. We'll come back to that later if it's not clear for some of you. But after the first security intrusion, the customer came back to us and say, okay, guys, maybe we change our mind. Now we want to split our management into parts. So even if you are taking care of that and thinking to it before, maybe you will face some cases where your customers or your client or your institution will take a decision, will make a decision at some point, and later on they say, okay, this was not the right decision. So you will have to face that, and you will have to know how to compose with it. Okay, so infrastructure can be either on-premise, local, or hosted in the cloud, AWS, GCP, Azure, etc., or kind of an hybrid of both of on-premise and cloud. Okay, but in your case, most likely, I would say for now, because in the IT world, we don't know the scale is there. Everything can change. So I would say for future, we don't really know how it will be going. So I think it's important for you to be concerned also by cloud. But most likely for now you will see only on-premise or maybe hybrids also. Okay, data center. Come back to this one. So data centers, they host server farms. They can host hundreds, thousands of servers, both physical and virtual. Uh, it provides continuous power delivery using UPS and generators, as we said before. Provides also cooling facilities for power dissipation. So this is also a very big challenge, guys. In HPC world, you will find, or I mean, not only in HPC world, but it's in the traditional, infrastructure world, you will find mostly air cooling. In HPC, it's another story. Uh, the density is generally much more high. I mean that what we call the TDP, the total dissipated power per blade. I don't know if every one of you is familiar with what is a blade. Just let me know if you're not sure. What we call a blade uh, historically was referring to server chassis, where you have a big chassis of 20 U's, and you have a server inserted as a vertical blade inside. But in HPC, when we talk about a blade, we talk generally about a node, a rackable node, as most of you may know, which contains inside more nodes. It is the case for build Sequana blade, for instance. Sequana cluster are made of these blades, and so in such cases, the total dissipated power per blades is incredible. It's something like 1 kilowatt, which is I would say very high. If you consider is that you can have up to 96, I believe, 96 blade per rack in Sequana, it makes a total of 96 kilowatt per rack. It gives you an idea. And this must be cold. So that's why the Sequana is using water cooling instead of air cooling. So this is an approach common enough in HPC world, but also in your particular case, I don't know for you guys what kind of hardware you are using. Are you using water cooling or air cooled or whatever? But it's also possible to use a mix of air cooling and water cooling. This is something that can be achieved because if you consider what is made on Sequana, the wall rack is cold. So it's a much more complicated cooling system than the common water cooling that you can see with a kind of a head pipe put it on top of a processor and and an external water cooling system. The cooling used for Sequana is cooling the wall rack and the wall motherboard, a bit like a cooling system for a car engine. It's exactly the same design, except it's that it is not water inside; it is glycol, and you have an external pump, but it's almost exactly the same as what you can have in your car. Um, Also, as we discussed just before, in the data center, the credo is the maximum availability by using indeed a lot of redundancy, since this is the basic. If the power and the cooling is not working, you cannot work, or you won't work a long time. You will have a lot of things that will break. Your performance will be affected as well, and you will run into a lot of problems. So here, just for to give you an idea, I gave you the four standards that are applied to data centers. So the formula is pretty simple. It's just the ratio of uptime on top of the wall time on a year. It means that how the ratio of how much minutes it has been on top of how much minutes in a year. So it gives you an availability. So tier 1, tier 2, tier 3, tier 4 are the different class of availability for data centers. So, but in the world of HPC, I would say you are not even in the first tier availability. I mean required, because I would say 99, we'll see on the next slide, I can't remember. Yeah, it's 7 hours and 12 minutes downtime per month. So it is something, it depends on your HPC system, but I mean, generally speaking, uh, you're a bit more relaxed in HPC world than you could be in an infrastructure where you are directly facing clients. You know, when you know, in other world where not Google, YouTube, and Facebook or WhatsApp, so you won't have the same concern in terms of availability. But just to protect your investment and make your hardware, get your hardware to run longer, it's always good to consider a proper cooling. It's not, I would say, a sacrifice. It's an investment. You know, put the right price for its power. Uh, and for its power supply, in particular UPS and so on, is never lost. So this is something you want to consider. So regarding servers, well, I said in the introduction, uh, I would say 99.9% of servers that you will see for now will be using x86 architecture. It is starting to change. It is starting because NVIDIA is not only now competing in the GPU business, but it is also building ARM. I don't know if you guys are familiar with ARM architecture. Maybe the most hardware sensibilized of you are already familiar with ARM, but to give you an idea, an ARM is a different processor architecture compared to x86. ARM is, for instance, the one that is used by your Android, by your iPhone or Android or whatever. They are using ARM architecture processor. Your switch, for instance, is using an ARM, and a lot of things they are using ARM, especially when it comes to embedded system. So ARM is a RISC, which means redundant instruction set computer. It's a kind of it's a family, it's a processor family. So it's the opposite of the x86, which is a CISC family, which is complex in instruction set uh, computing. And these are two different approaches. I won't go in details because it is a bit too much specific, and I would overflow on the time we have available for to discuss that. But just keep in mind that most of the server, at least for now, will be some x86. So basically, the same families in your own laptop or your own desktop computer. They are then quite similar to your own machine, but indeed much more reliable for sure. This is using and made of server-grade hardware, especially for capacitor, for power regulator, and so on. And also, they can handle multiple processor. They can handle a lot of memory. They are not using the same kind of memory. They are using registered memory specific to servers. That is, I would say, error fault tolerant, among other differences. And also, a difference is in the power supply, which are often redundant and are most of them, I would say, I can say 100% of the servers you will find on the market will use an active PFC power supply. PFC stands for power factor correction. It means that it will actively deal with cost fee, or I don't want to be too much technical, sorry, with the specific power factor and some I would say some current perturbation that could be caused by some loads on the same lines. So especially inductive loads. So almost all servers are using active PFC power supply. And another specific thing about servers is that there are almost of them using what we call an OB. I don't know if you are familiar with these terms. If not, I can elaborate a bit. What we call OB is a concept out of band. It means, or we call that a BMC. If you hear about BMC, I think it stands for base management something, whatever. When we say OB, it means that it's a kind of I would say a permanent door or a hidden door to access your hardware, which is not system dependent. So it means that you can see the BMC. OB is a generic concept. When I say BMC, it's specific to a server. So if you have at least almost all rackable server have a BMC on them. It must be seen as a server inside the server. Okay, but this one is embedded and is running in a totally isolated way and is out of band. It means that it has the ability to wake up the server and to stop it and to interact with it. It's a bit like if you could see, if you, for instance, to give you an example, it's a bit like if you could be at your window looking at the street and looking yourself walking on the street. This is BMC. For those of you that are not familiar with it, it permits to gain an access to your computer without having a system on it. So it permits you to deploy remotely, for instance, to interact with your BIOS and to do any kinds of interaction with your own server. So this kind of it's integrated to motherboard. It can be also in the form of add-in cards, but 99% of them are integrated to motherboard. A very last word on BMC. It's a bit specific, but you have to know it. It has the ability to share, to be bridged, sorry, in terms of network to the usual management interface of a computer. This can be very useful for cabling. It can save you a lot of cabling. So you can use the same wire to supply both the BMC dedicated interface, network interface, and your normal management interface on your server. So basically, when it comes to network, I mean, a server has always a management interface. So it means that it has at the very least one interface, or I would say two, even two, LAN 1, LAN 2, plus the BMC. So you have the BMC, which is completely independent of your system, that permits you to have transparent access to your system, even if everything is broken. That permits to stop the system, to shut down the machine, to power off the machine, to start it, to restart it, to do anything you want. Even if you lose your network connection to the machine, you lose your management. If you have a BMC setup and accessible, you are still able to connect to your machine and reestablish a network connection. So it's very, very, very useful. You cannot almost pretend do nothing on a server without a BMC. So you want to get this out of bin. And you have an equivalent on switches. It's the name can change, but I mean, traditionally, all manageable switches or network equipment have use a serial port console, which is also called a console port. This is using serial. So what BMC is doing is, for instance, when you connect to a machine which has no system available, which is empty or just a BIOS or whatever, it will use actually BMC to access in serial on your motherboard, and you can do the same with switches. It's called dedicated management interface, or it can take several names, but the concept is always the same. It's an out-of-band interface. So server chassis also can use such interface as well. Let me check for the time. Sorry. Okay, will remain 1 hour before the break. Just regarding the servers, when we said, oh no, let me finish on OB, so I will be exhaustive. The BMC and the command that you can send to a BMC, to a management server, are using the standard protocol, which is called IPMI. And IPMI is something which is standard over all the manufacturer. So if you consider each manufacturer had a dedicated protocol, which is such as ILO for HP, IDRAC for Dell. It can have several words, but all of them are supporting IPMI. And more recently, because IPMI is not very, very recent, it's a bit outdated. Recently, it begins superseded by Redfish, which is a very brilliant evolution of IPMI, and it's basically making use of REST API. So it means that you can simply, with basic HTTP request, administer all of your hardware and make a very advanced interaction with your hardware. So this is something very, very, very promising, especially if you have to deal, if you guys you have to deal with big HPC, or even if it's not in an HPC context. Uh, as long as you have a bit of a certain given number of machines, you will want to have a management for that. And IPMI and Redfish are tools, but you have also tools that we call CMDB, and maybe we'll come back to it later, which can permit you to manage your all of your assets, all of your data center from a single point, and having a database of all your assets. And this is something you will want in an HPC context, because it's not possible to manage efficiently when you have thousands of machines, or hundred of or thousands of machines. You cannot manage them without automation and a proper DB. It's just unrealistic to want to try to do it manually, and very underproductive. So just last word regarding servers. A server can designate a physical host, what we call a bare metal host, with an operating system directly installed on it, since such as your computer, for instance. You have your computer with a hardware, and on top of this hardware, you are running an operating system that is in charge of leveraging your hardware. Mm. So this is a definition of an operating system. Sorry if it's an obvious for most of you, but maybe for some it's important to refresh about it. And another category is what we call bare metal hypervisor that executes VM or containers. So this has been a revolution. Virtualization has been a small revolution for us. I remember when I saw it arrive a few years ago. I would say 15, 20 years ago. Yeah, it was a kind of a revolution, since we could consolidate several servers on one physical machine. So it has been really a gigantic step forward, and it's well, we'll come back on VM in more detail tomorrow. Yeah. So just keep in mind that a server can designate, sorry, a whole physical host or a virtual machine that is executing on top of bare metal hypervisor, which itself is itself executing on a physical host. Containers also are another level of virtualization. It must be seen as a VM, but as an even UPL level. So it's even more efficient than a VM. And we'll also come back on that when I will describe you in detail the virtualization. You will see the evolution from physical host to VM, and from VM to container. And there is even a step over the container, which is called serverless, but we won't see that. Maybe we just evocate it tomorrow, and I will explain you and describe you what it is. It is purely related to cloud, and what it is a trend since a few months of simplifying that, extremely simplifying a service, and not even using servers. That's what we call that serverless. And last thing, yes, servers are very often used in HA also. It's a very common setup to have them in high availability. We were talking about redundancy later, just before. So you will see that even in a computing cluster, which is the opposite of an HA cluster, you will find some HA at some point, especially for management or for very sensible nodes that we don't want, that we cannot afford to make to lose. So high availability is definitely something you will want to consider whenever you will have to provide service redundancy. So every kind of server of implementation has different high availability technique. It depends if you are using physical virtual machine or containers, and you have solutions for every kind of servers. There is a dedicated way of managing the high availability. Guys, any questions on these topics? Any remarks? Any questions?
Any question? Okay.
Hello. Can we consider that IPMI or
Don't hesitate to
Redfish
ask.
is like a
There is no stupid
preprocessor
questions.
of
And
the
well,
machine
I would be happy if you really
BMC?
have any question. It
Thank you.
means that I did my best to explain you. But
Okay, you didn't get that.
Um, you said that the BMC is like a different machine of the
I'm sorry, I
HPC.
have no sound. I don't know
But
if someone is talking.
my question is, even can we consider that IPMI or Redfish? Yeah, yeah.
I can hear you. I can
Um,
hear someone.
I understand that BMC is
Yep.
uh, another machine, and my question
Yes.
is how I consider that IPMI or Redfish is a preprocessor, because I understand that IPMI or Redfish is different between each manufacturer. Is it
No,
a
especially not.
preprocessor of the
It is
BMC?
meant.
Thank you.
No, it is meant. No. Okay. Just I will come back on BMC then. Okay. BMC is meant to be seen as a computer inside your computer.
Yeah.
And this one is very resilient. It boots in about, let's say, 4 or 5 seconds. It's generally an embedded Linux inside, which is using a special distribution, special Linux distribution. Generally, it's a BusyBox for the ones interested by embedded systems. You can look at BusyBox, Busy like busy and box like a box. Uh, since Linux can be used for everything or almost, can run on the smallest hardware, such as your Android. It's a pure Linux, and under the hood, your iPhone iOS is also a kind of Linux. It's a derivated Linux derivated. Mac OS X is also an Unix Linux. Right. A lot of operating system running on switches are also Linux derivated. Our most advanced switches at this time are running under Linux as well. And so a BMC typically is running an embedded Linux specialized for this task and extremely robust, almost in read-only. And it must be seen as a totally independent system with totally autonomous IP stack and an autonomous Ethernet interface. And IPMI and Redfish must be seen as a dialect that puts everyone a bit like, or I can say, a bit like if you consider, sorry, I would take an example. I would say, for instance, in Senegal, everyone can understand Wolof, but it's
Yeah.
everyone has his own has his own dialect. You know what I mean?
Yeah.
So IPMI and Redfish, I think they can be like seen this way
Yeah.
as an abstraction layer over the, each manufacturer implementation. And IPMI is the old dialect, and Redfish is a modern one. IPMI is UDP based, and it's not. Well, it's very very often used. It's the most. It is the most used actually. But if you want to take put a fit in the future, I would advise you to to go for Redfish, at least to consider it. It's a very modern implementation of IPMI, and it's definitely what all aspiring hardware guru should check. Definitely,
Yeah.
this is the future. Mm. And also, I would advise you just to close this point, but because it's really passionate, we could spend hours discussing about it. I would strongly advise you to consider a brilliant project, which is a courtesy of DigitalOcean, which is a well-known cloud provider, very professional, and they released their own tool that they were using internally, that's built internally to manage their incredible level of hardware or different hardware and etc. Which is his name is Netbox. Netbox is a brilliant project, really something impressive, and it requires investment to not I mean not financial, and it's an open source. I won't discuss of closed source software anyway, or almost not. So it's a pure open source software. It needs to be practiced, to be mastered, but it will give you an idea of what you can do with the CMDB.
I guess.
Yeah, really. But it's maybe not the first thing you will want to consider, but at least you have a pointer to it, and you know which direction you want to go if you are called at some point to implement the CMDB.
Yeah. Thank you.
So, yeah. All right.
Thank you. Okay. Thank you. I just want to go back to the EPMI interface, and I want to ask if you can the server who are accessible through a web a browser, are they APMI or Redfish? Because I have a server who are accessible through his management interface, but through a web browser. Is it APMI or Redfish?
Both of them can provide that. You are talking about saltation, right?
Yes.
Yeah. Well, both of them are handling that for sure. I will give you a short answer. Um, Mainly, sol is it means serial line over IP. I think something like that. BMCS can handle to forward graphical frames. It works well when you are local. Okay, it's X11 forwarding, so it's pretty heavy to carry on slow links. And most generally speaking, I would say that an IT professional, a Linux IT professional, should not need to forward video. Console should be enough. I don't know if you guys follow me.
I don't get it.
Okay. What I meant is, okay, to answer your question, both IPMI and Redfish can provide you what you want to do. But what I meant is, if you have been using your browser, it is because you wanted to access a graphical application or what?
No, it's accessible through the browser, and then
Mm-hmm.
it's use Java web service to show me the
Mm,
graphical
yeah, yeah,
interface. It's an
yeah. Java
Oracle
applet.
server.
Was it Supermicro or what? What was it? What kind of hardware?
It's a Oracle X7 server.
Mm, I see. Okay. So this is a bit specific. First, Oracle is not a server manufacturer, uh, while they have bought Sun. So it's either a Sun or something like that. My answer to this question, just simply to avoid having something too much specific, but what do you want to access using this web browser? What do you try to achieve?
Uh, it's to get the management for the server itself, like power it, management
Oh, okay.
the
You
boot.
mean to access? Okay, I understood. Okay, so it's not even for forwarding your screen.
No,
It's just for basic comments, right?
yes,
Rebooting. Okay, so you can just forget about it. It's useless.
okay,
Forget about it. This is
okay,
bullshit. We don't like. Yeah, I know pretty well what you mean. It requires. It's a kind of Java applet. That's it. And when you try to access it using your browser, it takes forever and generally end up with failing, right?
yes,
Yeah. Okay. So we are talking the same shit.
okay.
Well, you have the answer to your question.
Thank you.
Keep away from non-standard shit. Keep away from Oracle. Keep away from Cisco, and as much as you can. That's the answer to your question. Everything you want to do, especially basic things like that, should not need a browser, a web browser. Because if you put you in a situation when you have broken everything, the only thing you remain is just an SSH access and just a poor console. You know what I mean? If you are responsible of starting or rebooting or do whatever commands that should be handled, that can be handled by IPMI, and you are relying on the web browser to do that, it means that you will have to have a fully functional graphical interface first.
No, I
You
don't
know what
need
I mean?
no, I don't
So
need a fully a graphical interface.
if you want to access a web browser, I don't see how you will do without that.
Oh, that,
You don't need, but what if you require, if you are using a web interface to access something that you could access using IPMI instead, you will use a web interface, so graphical interface for nothing.
okay,
You see what I mean?
Yes.
So basically, just to make it simple and short, basically a BMC should be managed using IPMI. I don't know no BMC on the market that is not supporting IPMI.
Okay.
And
Thank you.
yeah, and yeah, a very last word on that for the most interested of you. Um, Not that every manufacturer has his own BMC firmware, but I would say 99% of the chipset, the hardware used for BMC is made by Aten, and it is AST 2500 something. So it means that the firmware which is used by your BMC is not really specific to your manufacturer. In other words, I mean that there is a project which is called Open IPMI or something like that, Open BMC, sorry, Open BMC, which provides you a very powerful firmware, alternative firmware for BMC, and get rid of the proprietary one that has been injected by your manufacturer.
Okay.
So this is the first point, and the second point for you guys, just a bonus. If you are familiar with the brilliant Raspberry,
Yes.
with just a simple Raspberry, you can build a brilliant BMC, much more feature than the very expensive that you can find
Okay.
on high-end servers. Yeah.
Okay. Thank you.
So yeah, but this is something outside of scope, but this is the kind of tricks that can be useful.
Okay. Thank you.
So tell you that you can build a BMC for you by yourself for $50. Yes, Raspberry is definitely your friend. It can be useful for a lot of things in data center. You can do connected PDU with it and things like that. When you see how cost an IP driven, I mean connected PDU that you can access to disable power, for instance, for on a given outlet and so on. If you are a bit involved in do it yourself and so on, and you have serious guys, you can imagine brilliant solution based on that without investing a lot of money and having the same result at the end. Mm. Well, it is 30. Let me check the schedule. Okay. Well, remain 30 minutes till the break. Well, we'll go next. Storage. Introduction to storage. So first thing I would like is to introduce basic storage concept, and I would like first to make sure that the different storage kind are clear for you, and disambiguate also three terms: storage, backup, and archiving. So archiving, as written, is meant to be securely stored without no expiration. It means that something which is archived will have a special bit set and will never be reset. So the archive bit is set, and it's a backup. And if you talk about backup strategy, this is something that will never move, that will never change, that has no expiration. Backup is meant to secure some data that are living on some machine and so on, in the intent to restore them at some point. And it can expire, it can be replaced, refreshed, etc., etc. And storage is everything under that, and this is the hardware used to host data, whatever the use of this data. So it's just I just meant to clarify for all of us. Okay, now it's different kind of storage. Storage is very, very important, guys. You don't want to underestimate the importance of storage. Before going further, I would just share the reflection with you. Probably even at your laptop level, you probably have noticed that it tends to be slow sometimes, and most of the time, I mean not in an HPC context, but generally speaking, or even if I go back to history and histories that I even not known by myself, but there has been a time where the storage was waiting for a processor. Yes, guys, it happened. It happened in the past. I didn't knew this time, but there has been a time where storage was waiting for a processor. Yes, and since a long time, it's not the case anymore. And on PC, the storage did not evolve for a long time. Maybe some of you still have some parallel IDE interface called the ATA. So there has been a lot of evolution in storage, but only recently. For a long time, storage has been kept very, very quiet. There has not been a lot of disruptive technologies and so. And but since a few years now, I mean, I would say almost 20 years, uh, and until very recently, the difference between what the modern processors and the modern chipsets and memory throughput could permit uh, was not without any possible comparison with what the storage could handle, either in read or in write mode. So it means that, and I think it's even more pregnant on your own laptop, for instance, you will create a very big bottleneck with storage. If you do not design your storage well, you will create a bottleneck, but even more than you think. It's a big hard to figure it without a diagram, but believe me for sure, even on without taking any bench, any measure, just try by yourself of replacing your hard drive without touching nothing on your processor, nothing, just replace your hard drive with a brand new hard drive or even with an SSD. Jump for mechanical to SSD. It will be day and night. And jump from mechanical to M2 or PCI, what we call NVMe. So directly plugged on PCI bus, you will get terrific performances. Especially in the feeling, because on most of our, indeed, HPC is a different case, but we'll go it later. It's just a general consideration that I'm trying to do here. Uh, for most of the use, you will not use really your processor. It will take most of the time to sleep. However, when you need to access your data, you want to get them right now. If you don't have them, you will struggle to access your data. It's not comfortable, and it tends to add latency and give you a very slow feeling because your disk is struggling to and your processor is struggling to access the disk, and the disk itself is struggling to access the data. And in better case, it's just slow. In the more complicated case, you can go in. Oh, sorry, I don't know the name in English for that. Yeah. Anyway, you can go in a case where the interrupt generated by the storage will even add even more load to processor. So you can very actively load a processor very highly, even make it raise 90% load because of a defective storage. It's very easy. So storage must be something carefully designed. From your laptop till your biggest cluster, you want to have nice storage and working flawlessly. Yeah, because another enemy, I said spoof before, but one of our other good enemy is bottleneck. Bottleneck is definitely something you want to tackle. And there is a bottleneck you will see in almost every stage, every part of your IT infrastructure, you will find some bottleneck. Even if you look at your computer, you will find a lot of bottlenecks. Interface are bottlenecks. The first bottleneck you can find in a hard drive in storage, for example, the most common one is the SATA. SATA is almost, I would say, a maximum 6 gigabit, which is a lot, but it has nothing to compare with the PCI bus, which is just behind. So that's why the first evolution has been to go from mechanical disk to flash disk, which is a great evolution. But you are still you have still a big bottleneck with SATA compared to what the PCI bus can handle behind. This is why we released the NVMe. So it removes the last frontier, the last bottleneck on the storage. You have a direct, a highway to processor or to memory. And I can tell you it's impressive. Maybe some of you on their laptop have the, if you are curious, you can check for an M2 port, a port called M2. M like M and 2 like number 2. So an M2 port is a new standard for NVMe on laptop, on even on fixed motherboard. It's more and more common. And it's a very small slot that you can find generally under your laptop. And so the M2 defines the physical interface, and the M2 itself, it's made to interface NVMe or hard drive, SSD hard drive. But M2 defines the form factor essentially. Internally, it can be a SATA or a pure PCI, or a mix of them, I believe. I'm not sure. But at least it can be SATA or PCI. And if you have it, if you are lucky enough and your computer is using as an M2 port, and this M2 port is native PCI, you can get terrific performance by replacing your hard disk by an M2 PCI or M2 NVMe. This is really nice to try. And indeed, the reliability does not compare with a mechanical disk. A mechanical hard drive is, generally speaking, in enterprise, it's something like 3 years. In HPC, depending of how you are soliciting it, and depending of the hard drive class, you can, with a mechanical, you can aspirate about 1.5 year of expected life. So, and this is not the same with SSD. SSD has a lot of advantage, not only for performances. It's also when it comes to data integrity. You have to think to that, because if you lose your data on a mechanical hard drive, it's very, very, very hard to recover. You can always recover them, even if you burn it, you can recover it if you have means for that. If you can pay for that, you will recover it. We have a few companies around that are able to recover anything, but it costs a lot of money, especially on mechanical disk. And for SSD, I would say indeed it's always theoretically, but I would say that in the worst case, you won't be able to write anymore, but you will still be able to read. That is a big difference. The worst thing that can happen to an SSD is that the cell, because it's use flash memory cell that can keep that can switch and keep a consistent state, either 1 or 0, and that's it. An SSD, flash memory, is a very big matrix. So everything, just as a reminder, guys, everything you can digitalize can be represented with 1 and 0, right? It can be my voice, it can be image, it can be anything, it can be any file. Anything that can be represented digitally can be written in a matrix at the end. So an SSD flash memory is just a matrix of 0 and 1, that's it. And the good thing is compared to mechanical disks that are using magnetic effect and that are, you can say it's a kind of analog storage, it's much more fragile and subject to alteration. Compared to a flash memory that, well, you can still burn the controller, but it's always easier to repair than recover data from a mechanical hard drive, because whatever the problem, the flash can still be read. As the worst case, it will refuse to write, to change its state, but you can still read. So that's why you want to prefer when you can, and the price is more and more affordable. The price per gig is decreasing more and more. And it's, by the way, it's also fluctuating because of a new blockchain money which is based on storage, but that's another story. Generally speaking, the SSD and flash memory will continue to to decrease, and the traditional storage is not dead anymore. It's not dead not anymore. It's not dead at all. There is still some room for it, but for very, very big capacity. For standard capacity, if you have a choice, okay, you will pay more, but depending on the capacity you will require, it's always a better choice to use NVMe or SSD, generally speaking, rather than mechanical disk, especially for, even if you consider only reliability and investment. I think it's okay for this storage introduction. Let me just go to next. Okay, different kind of storage. So different kind of storage we know is we have the DAS. DAS stand for direct attached storage. It can be, for instance, in your laptop, your hard disk is a DAS. Okay, it's a recent term we used that has been introduced actually after NAS, just to differentiate it efficiently. But initially, we were not using the term DAS. It's something that appeared a bit recently. We were just saying NAS or SAN, that's it. Okay, and the fourth one is cloud. I will come back a bit just after on that, because first of all, I would like you to make sure that you know the difference between block storage and file storage. Block storage is what your operating system is doing on your hard disk. It means that you have a direct access to the disk you want. Okay, you have a direct access because you have a physical disk, an interface that can permit to connect to this physical disk. You have a partition and you have a file system that permits you to access this disk. Or so even if you are using it through a file system, we are considering this is a block access. You are using block mode versus file mode. Okay, so a locally attached disk is using block mode. So in DAS we are in block, in NAS we are in file, in SAN we are in block, in cloud we can be either in block, in file, or in object. This is three other modes. I will come back a bit later on it. Oh, DAS. We said DAS is, for instance, your big server with a few disk bay, and your disks are attached to your server, and that's it. This is DAS. Okay. NAS means that you have a dedicated server which is actually exporting using either SMB or SMB, sorry, the ancestor of CIFS. It is the protocol SMB, simple message block, which was the ancestor of CIFS, which is a modern uh, file sharing protocol used by Windows, or NFS, which is a very popular and venerable file system used mainly in Unix and Linux, but it's very efficient. It has a few drawbacks, however, but it's a very efficient way and economical way to provide a read-write access, concurrent read-write access to some machines. It is really something you want to consider when you have to provide a read-write access to more than one machine in a simultaneous way. It is the most efficient and economic way. Uh, well, NFS has proven it works and it's reliable. So it will be often a good choice for you. However, there is a few drawbacks that you will discover, and it's pretty well documented. Uh, so this is for NAS. Okay. So when we say NAS, you must think about network and file mode access. Okay, so a good example, for instance, is you have commercial filer, such as the one from NetApp. NetApp has built his fortune on the filer. After NetApp has bought a well-known company called LSI, so now it's a bit confusing if you say when you say NetApp, you don't really know if you are talking about the legacy NetApp, which were mainly integrated filer, hybrid filer that could act as a NAS, as a SAN, and other features. It's definitely not something I would recommend. I mean, not NAS, I mean NetApp, those filer. They are often known, the reference starts like FAS dash something. I, I do not say it's bad. I said it's expensive. When you buy it, it's expensive to own it. Hmm? So when you are, some of you maybe deciders, maybe you have managing budgets or so on. So just think to that. When you are about to sign for NetApp, okay, you said it's good hardware, it's reliable, it's whatever, but it will cost you to buy, it will cost you to own it. Hmm? And I would say, as I said before, for BMC, you can build your own NetApp by yourself. If you are designing carefully enough your hardware, You can design your own server, you can design your own NetApp. Because you will pay a lot of money to NetApp to get something which is, yeah, I can say it works, but data on tap is it's not something very commonly known, and once more, it's just something that will cost you a lot, and that will force you to buy some disks that are normal enterprise disks, but you will pay them 10 times the price because they are relabeled with NetApp on it. And not only relabeled, they are also using a special firmware from NetApp, and the NetApp controller is using a special firmware as well, so you cannot use a foreign disk. You see what I mean? And there is no good reason for that. The only good reason is that NetApp wants your money. Hmm? So you have way to circumvent that also. You can dump firmware from NetApp from another disk and reapply it on the same disk, but you have to be careful on what you are doing. But there is always ways to circumvent that. But the world is message I am trying to give you is keep away from non-standard stuff. Keep away from proprietary shit. This is not what you want. So HPC is costing a lot of money, and you can save a lot also by avoiding to put your feet in the first trap. So I would say that's my advice, but I would say the best server, well, for HPC, it's a bit hard it's not tomorrow that you will build your Sequana, for sure. But for most of purposes, there's a lot of things that you can do by yourself, and that will be by integrating existing stuff, I mean. And the difference will be made, or the benefit for you is the price, it's the knowledge also. You will have a great mastering of what you are managing. I can give you an example for Google is building its own servers, and for years they have been designing their own power supply. And if Google designs its own power supply, they have a good reason for that. So we don't. I'm not advising you to, okay, guys, develop your own power supply. This is not my my message, but at least know your hardware, know what you have, and you will get a much more efficient use of it, and you will save a lot of money, not just a little, a lot of money. So that's not it yet for the storage, but that was very important to say that. So basically, if you want to get a NAS, this is typically something you can do by yourself. I just give you a last pointer in this regard is check FreeNAS, a project called FreeNAS or TrueNAS, true like true and free like free, NAS, N-A-S. This is definitely something you want to check, guys. You will get a brilliant feature on it for the price of nothing. It's just up to you to check for the appropriated hardware. But using FreeNAS or TrueNAS, you have a first-class NAS that has can compete greatly with $100,000 of NetApp storage. After, it's up to you to purchase the right hardware, to find the right chassis, but there is room for everyone. And once more, we know most of you are working for universities, and so it's always, even on the educational parts, it's very interesting, I think, for your students to be part of such a project and it's also make of them accomplished professional uh, when you are really involved in what you are designing. When you are designing your own stuff, you are much more than involved in you. You have an incredible level of knowledge at the end. Mm. So Sun, Sun is I would say another story. uh, Sun, um, Sun is is a block access mode. So a Sun is literally a storage area network, which means um, that all of your all device attached to Sun will be presented to all machines that can access this Sun as a local disk. So it's very performant. I mean, it offers the same than a NAS, except that a local disk can be virtually attached to any kind of machines. But Sun is a higher ticket. For now, Sun is still pretty costly, and you can make some do it yourself with Sun. It's possible. TreeNAS and FreeNAS are providing IceQZ, what we call IceQZ, and IceQZ is a brilliant technology also. IceQZ and FCOE are I mean affordable technologies, affordable Sun technologies. Mainly on Sun, you will see fiber channel. This is the most used for Sun, but since a few years, IceQZ is competing, has begun a very serious competitor against fiber channel. So it's like that in IT. There's not a lot of constant things, of a fundamental. So a few years ago, I would not have said you, okay, go for IceQZ. Now I can say, okay, go ahead, guys. You can go and build your Sun for peanuts using IceQZ. If not, it will be fiber channel. You can also do by yourself by fiber channel, but it's another cost. And it's also in big Sun, you involve also switch behind, which means there are the same fibers. That's one you can use in Ethernet, but they are not the same frames. This is fiber channel. This is definitely something that has nothing to do with Ethernet, but it can share the same media. It can share the same physical layer. Okay, but a fiber channel switch is often quite costly equipment. You can find some affordable and very efficient on traditionally Sun is Brocade. When you say Sun, when you say switch, FC switch, using Brocade. They are almost the only one. It's a bit like Broadcom for switches. It's very hard to find a switch, whatever the manufacturer, which has not a Broadcom chip just behind the port. It's very difficult. And at the same, it's you can find whatever Sun you want. It's very difficult to not find some Brocade in the switch and some LSI in the storage. It's very, very, very difficult, whatever the brand. If you go for Dell Total Storage DS whatever, you will find some LSI inside. If you go for Dell Power Storage range, you will find some LSI inside, etc., etc. If you buy an Ethernet switch from Dell, from whatever manufacturer except Huawei and a few others, you will find some Broadcom inside. Okay, so that's it. So Sun is definitely something much more professional, I would say more complex, but it permits you also to achieve a lot of cool things with when it comes to storage. We'll come back a bit better tomorrow on this one if you want. I don't want to make your head too much full of all of kind of things. I will try to finish on this one. After you have cloud storage that we didn't show. So cloud storage is pretty cool. We'll see tomorrow a bit better, but it permits to do all kind of things, almost all kind of storage access you can imagine, plus object storage, which is an even new kind of storage. And it's not only for cloud. You can have object storage or storage object using distributed file systems such as Ceph, for instance. Okay. And also on another well-known object storage provider, but in cloud, is Amazon S3. S3 from Amazon. It's the historical, I would say, storage object offer on the market. Okay, what next? Okay, we'll go for RAID. I said, you guys, redundancy. You will have redundancy at each level when it comes to infrastructure. Sorry. So let me introduce quickly with RAID. We'll come back tomorrow on that. With I hope a few detailed diagram, because I don't like to speak without giving you a bit of diagram, especially for that. But let me introduce quickly RAID. So RAID stands for Redundant Array of Inexpensive Disk. This was the term at the beginning. It has been invented, I think it's something from Berkeley University, I'm not sure. But anyway, the purpose of RAID was mainly to provide redundancy at the beginning. And as much as a lot of redundancy technology and so on, we found at the end that it could also used to push some physical limits we had on disk. So RAID is addressing a few different things. The first one, the first idea, was to provide extended storage space or extended or increased redundancy. So I will check not by RAID 0 but RAID 1, because RAID 1 is for mirroring. Okay, so on the RAID 1, every little thing which is written on a given disk in a RAID 1 set will be replicated on the other member in the set. If you have two disks, for example, you aggregate them in a RAID 1, everything that will be written on a disk will be written in real time on the other disk. The thing is, by using that, you are offering a protection against data loss, because if you're, again, physical damage, I mean, you are not protecting yourself against, I don't know, a bad manipulation or something like that, or a human error. For instance, you delete a file. Okay. The thing is, there is a benefit also of using RAID 1 is when you write, you are writing on both member, and when you read, you are able to read on both members simultaneously. So theoretically speaking, and not only theoretically, you can feel it. If you are using RAID 1, you will increase your read throughput. Okay, and you will theoretically also it's proven in the practice, you will also reduce your latency. Okay, but mirroring is not that efficient. It means that because why? For instance, especially if you use a slow number of disk, a low number of disk, if you have two disks, it means that your total capacity will be your two disks divided by two. Okay, so it's not very interesting, I would say, as it, but it can be useful to protect against. Once more, it won't protect against a human error about ransomware, encryption, whatever. Everything you do on one member will be replicated on the other members. So keep that in mind. And the red zero called striping is very interesting also. It has been used initially to extend to go beyond the limit of the previous hard disk that could not um, that that could not handle very big capacities. And so the red zero had been suggested as a way to expose a logical drive made of two different drives aggregation, uh, which is at our time a bit can appear a bit old style, because we have no problem to get big capacities. So it could be at first glance seem to be a bit outdated. However, Red Zero has a very big advantage because it's using striping. It means that every data which you are writing on a hard disk will be divided on the other member of the red set. So if, for instance, you have two disks, if you write one data, it will be written half on a member and the other half on the other member, using an exclusive or what we call mathematical or logical XOR function. Okay. Compared to red one, which is using a logical AND function. So, but remember the XOR, exclusive OR, because this is something you will hear again when we'll talk about storage controllers. So the thing with red zero is if you aggregate member disk in a red set that are using red zero, you will end up in one logical big disk, which is the sum of all your hard disk, all your members. So, well, it's nice. It appears to have a very big disk, but the thing is, if you lose one disk, you lose everything. Okay, and the real advantage of red zero, because it's for now at our time, we are not using it just to get big contiguous space. We have much more efficient strategy to do that. We have a LVM for that, which can permit to create a big logical volume. But red zero is still used when it comes to fine performances, because when you're using red zero, you divide by two your latency. By two if you have two disks, by three if you have three disks, by four if you have four disks, etc., etc. And you multiply your read and write performances. The more disk you put, the more performance you have. This is for red zero. But red zero, if you lose one disk, you have no chance to recover the data, at least by using red redundancy. So you have no redundancy at all. It's not made for that. So if you have a backup and you can handle that, it's up to you. Or it's often used for scratch data, you know? Scratch is it's like a temporary space which is used, or is this a generic term? When I say Scratch, I mean in IT, it refers to a spool directory or kind of spool which is meant to handle garbage or temporary data, but we often like the Scratch to be quick enough. Okay, so I would say one of the most used common use of a RAID 0 volume is when you want to get the most performance as possible, and with disregarding the data security. So it's good for diskless for stateless machines. What I call stateless machines are machines that are not using states. I mean, that is not generating data that will be reused. Since a compute node, for instance, it has no data on its own. It can generate data, but it will be stored on external volume. So we can we can say more or less this is stateless. Okay. Typically, a container that we'll see later is purely stateless. It has no state. It has nothing. It has no memory. It can be rebooted. It can be destroyed and replaced. It's not a problem. So this is a bit what is a compute node is typically a very stateless machine. We don't care. You can burn it. It's not a problem. You replace by another. You have lost just nothing. Okay. Now let's go straight to the next RAID level. Or yes, there is other, but the next very common, which is RAID 5, or also RAID 6, which is same, slightly different. I will explain you what it is. So RAID 5 is an evolution of RAID 0, which has been designed and intended to provide a response
Hello.
to RAID 0 in regard of the reliability.
Question.
Yes, sorry. Go ahead.
I want to ask in HPC cluster, which red
Mhm.
level is the recommended one?
Mm, I will not answer this question by a simple level. I can tell you that a mix of mod are used depending of what you need and what's the use case. If you took for a node, for instance, it's common to have, as they are stateless, it's common to have a RAID 0. If you have only two NVMe, for instance, I mean only, it's good if you have two NVMe, which are already very fast disk. If you aggregate two NVMe or two SSD in RAID 0, you get even more terrific performances because you aggregate the bandwidth of those two disks, and you end up with very, very, very slow latency storage and very high throughput. So it's very sensible benefit to go for RAID 0 in some configuration, but in some others, if you consider, for instance, a node not involved in computing directly, such as the management or so on, which can handle sensitive data, you will probably want to go for RAID 1 since it offers a level of redundancy which is appreciated, something that we are looking for in such situations. Does it answer your question?
Yes, thank you.
Hello? Can you hear me?
Hello.
Yes. Okay. No, I would just want to make sure it does answer your question.
Yes, you answer. Thank you.
Okay, fine. So the next red level, I did not evocate it now already. It's red 5. So red 5 uh, is the aim of red 5 is to address the lack of red 0 in terms of security. It works. It's also a striping algorithm. But the difference it is very intelligently storing a parity that permit to reconstruct the XOR. If you are interested, you can look for XOR logical equation. You will understand what I mean. Or tomorrow, I will make a demonstration using a small diagram to explain how we can recover using parity. We can recover stripe. It means that when the data is written, it is splitted in stripes, and each stripe is written on a member and -1. It means that, for instance, if I have 5 disks, my data will be divided in 4, okay? And the fifth disk will be used to store the parity that will permit to reconstruct a missing or deleted drive. Okay, now if you consider this mechanism, Red 5 is clever enough to do that, but by changing the parity disk at each write, sorry, which means that you can always lose a hard disk. You will be able to reconstruct it with the distributed parity. So to make simple, red 1, security, red 0, performance and volumetry, red 1, security and less volumetry, and red 5, best of the two worlds. So you have performance since you are using striping, and the more disk you will put, the more performance you will get, and you are not losing the storage space, and you are having the benefit of the red 1 since you can afford to lose one member at a time. Okay. And red 6 is exactly the same since it has a double parity. So you can afford to lose 2 disks simultaneously, which I personally never saw. Even you burn the whole thing because you have neglected your power quality, so you lose your whole storage because of an overvoltage or something like that, or you lose one disk. But I never saw 2 disks crashing simultaneously. No. So I think that could be it for storage. And what's the time? We're already overflow.
Hello.
Mm,
I have a question. When you tell when you tell red 6, you mean
mhm.
red 10? In the literature, I have
No, I did not mean red 10. Red
red
10,
10.
sorry, I
Yeah,
did not mention red 10. Okay, I will just to be exhaustive. Red 10 is something you will almost never see. Uh, red 10 is basically a red 1 on top of a red 0.
yeah.
Yeah.
But
So that means you are doing a redundant array of 2 disks, which means, for example, if you want to do red 10, you will need to have 4 disks.
yeah,
And for the price of 4 disks, you will have the capacity of 2 disks. And so you are right in the way that RAID 6 can be compared to RAID 1, but it's much more efficient to use RAID 6 than RAID 1. With RAID 1, you are losing a lot of capacity. You are still losing the half of the capacity. But I agree with you, sir, that RAID 1 is offering almost the same functionality level in terms of redundancy that RAID 6, but it's just at a glance, I would say. It's in reality, you will always prefer RAID 5 or RAID 6, one of them.
Yeah.
Mm.
Thank you.
And just, I would like to add something important to me, I think. Um, well, as for a few things in when it comes to IT, the best practices are not meant to stay. So I want to share with you that when I began in this industry, and also first of all, before attempting to talk that, I would just make sure that I precise that you have two kind of RAID implementation. Despite of the RAID mode, I mean, you have two ways of implementing it. You have software RAID and hardware RAID. That's right. I talked, if you remember before, I talked about the XOR engine. Okay, XOR engine is used when you are using RAID 0 or RAID 5 or RAID 6, since it has to do an exclusive or logical operation. Okay, and in the past, software RAID, which exists since a long time, was a bit deprecated since the processor was not powerful enough uh, to be compared to what you could achieve with a dedicated controller with a dedicated hardware XOR engine. I don't know if I'm clear. This is what we call the hardware RAID. You have a lot of controllers that are offering hardware RAID. So there is pro and cons. I will give you my point of view in this regard, and probably you will make your own idea. But what I can say is, when I started with storage a bit more than 20 years ago, the only serious option when it comes to enterprise storage in using RAID was using hardware RAID, which was already costly at the time. But this is not the only thing with hardware RAID. Is if you are using this point, okay, you don't have to matter on your operating system level. You have a total abstraction. You won't see if, for instance, if you have 10 disks and you aggregate them in RAID 1 or in RAID 0 or in RAID 5 or in RAID 6, at the end you will end up with one logical volume. But for the operating system, it has no way to know that it is not a single hard disk. It has no way to know that it is talking to a logical disk, because everything is managed by the hardware controller, and in the hardware controller embed an hardware RAID engine, hardware XOR engine. Okay, so you will say, okay, this is pretty cool. Yes, it's cool, but if you break it, if you attempt to break your motherboard or to break your controller, if it's on a separated controller card, basically, if you are not finding the exact same controller with preferably the exact same firmware version running on it, you won't have no chance to get back your data, even if no one of your disks is affected. So this is why, personally, I will not make absolute recommendation, but I would say, okay, think to that before you design your storage. Will you be using an hardware RAID controller, or will you use the Linux kernel driver, RAID driver feature? And from my point of view, I can tell you that at this time, with modern kernel and modern machines, the performances as you can achieve with software RAID in Linux are just insane. It's even better. That's what you can have on some hardware controllers, minus the cost. But plus a required level of knowledge in managing RAID software in Linux. So this is up to your appreciation. I would say that maybe the best, as we said, for RAID level, there is no absolute recommendation. I avoid to make absolute recommendation in general, but especially in this case, I would say it depends in which case you are. It depends how much spare you can have, which availability is required on the machine, which are the budget constraints. You see what I mean? So the question, once you have all the information, you can make your own decision and say, okay, should I go for hardware RAID? Should I go for software RAID? So this is an important thing to consider, an important question to answer, I mean, because it will make the difference when it will come to a disaster recovery. But I would say if I only have one absolute recommendation disregarding hardware or software or RAID level, it's to know what you are implementing. I mean, in other words, I would say you are in a danger if you are in a situation when you have a system which is working and you just don't know why it is working. I think it's summarized a bit a lot of things. So the problem is not when you have a crash. The problem is, from my point, I would say problem starts if you have something which is running and you cannot explain why. So whatever the choice you make sure you can master it. If you go for hardware RAID, make sure that you have the appropriate spare parts and make sure that you tried already to replace them. If you didn't do that, you cannot consider you are safe, because you will put your stuff in production with your data on it, and when it will attempt to crash, either you won't have the spare, or you will have the spare, but you will discover that you have the wrong firmware version on it, and you cannot recover your data, and the stress will go, and you will start to explore other way, and this is when the problem will occur. Because at the beginning you will have just motherboard burnt or RAID controller crashed, or it can be a software issue with your RAID or whatever, or just a defective disk, or normal defective disk. It's something that can happen in a RAID set life. But if you don't know how is your RAID working, this is where you will get into trouble. Let me give you an example. I mean, something lived a few times. Customer has let's say, I don't know, maybe a big bay with let's say 100 hard disk or 50 hard disk. All is in RAID, hardware, whatever, brilliant, very redundant, everything goes fine. It on a given volume set in RAID 5, it has a predictive failure and then a failure. It will send a technician on the DC, and the technician is not here to make a decision to say, okay, I will remove this disk, or what. You guys will be the people that will say, okay, this is this disk from this slot. I will highlight for technician, so we make sure that in row number X and column number X, this disk must be changed. If by ever you are replacing the wrong disk, you'll lose your last chance to recover your data. Just because you are not knowing what you are running. So beware of that. I can tell you a lot of stories like that. Same for backup and bad restorations and customers that had a backup, a working backup, that wanted to restore, but they didn't even try to restore. They didn't never run a disaster recovery plan drill. So when it comes for real, they are not prepared. They are under stress because they crashed, they want to restore, and they restore at the wrong location, and they destroy another set of data that was intact. Or people that have a backup, that feel this is another very common one, that have a backup which is not properly monitored, and they rely on this backup. They have an attack or something like that, they want to restore data, and they realize when they want to restore, then they have no available backup. Because they are expired, because the tape drive is fucked, because whatever reasons. This is so common. So when you are in such a case, you still have if you have money, you can still recover your data. It's not just a question of money, but it costs a lot. When it comes to enterprise, or when it comes to a high volume of data, or when it comes to RAID first. When it comes to RAID, the price will change because it's not the same rate for data recovery. So that's why you don't want to play with storage. Definitely, you don't want to play with power supply, with UPS, with storage, with infra in general. Yeah. And the most your calling will be bad, the most your hardware in general and your storage in particular will fail. And that's why I would add, just for storage, that I think I can say, while I don't like a very absolute recommendation, but I can do a global one for storage regarding a choice of distributed file system. Definitely, I would say Ceph is a choice for a lot of reasons. Because if you go for Ceph, you open the door with professional storage, with distributed storage, and with I would say a new generation of storage, all is integrated in Ceph. It means I won't go in detail about the product, but the cool thing in Ceph, it has been thought with reliability in mind. it has been designed with reliability and scalability in mind. And we also know that reliability and scalability are well linked. I cannot tell you how much clients I had to support in L3 level because they crashed their whole storage during next storage extension operations. See what I mean? So, and for this reason and other reasons, distributed storage such as Ceph, Ceph are, I think, are the future for context like yours. Also, because another reason for that is Ceph is playing very well with heterogeneous hardware. It is not it is not picky regarding. I mean, you can have a very different kind of hardware, cheap, high end, middle end, whatever, from different source. You can aggregate them together and Ceph, which is brilliant, and it is a. I think it is a modern answer to storage, because you cannot imagine how storage can cost when it comes to storage bay and associated costs as well. And I mean, such as a lot of things, but especially for storage, what we call the TCO, the total cost of owning, is very, very high when it comes to proprietary storage solutions. So definitely my advice would be to go for home design solutions, or at least to mastering what can be on top of a lot of home design solution or even commercial solutions, because Ceph is embedded in commercial appliances such as FreeNAS also. FreeNAS, TrueNAS are also embedded in commercial appliances, but with this approach, you have the opportunity to do it, design it, and build it by yourself. Okay, guys, I think you want to break maybe. Oh, I realized I shut off my camera. Sorry. Okay, I'm better now. Is there any question I could answer?
So, thank you very much, Kamai.
On storage or anything else you want to discuss?
Questions on storage or anything that we have discussed, please? Question? Question? Okay, contribution. Question? Seems we don't have question. Yeah,
Okay,
please.
fine.
I just want to make a little the recommendation now. to Kamal. Yeah, please, we want to gently or kindly request that please, probably in tomorrow class, because we have people that are not that experienced as such among us, and probably if you can help us, like most of the thing you discussed today, you discussed about RAID and some other technology. If you can help us with some of those pictorial diagrams so that they can be able to
Yeah, sure,
visualize
sure,
what you
sure.
actually explaining to us. I
Yeah,
know there are people
yeah.
here that have a good understanding of what you are discussing, but at the same time, there are
Mhm.
people among us here that have not done
Yeah,
anything on RAID before and
yeah.
other things. So if you
No,
can,
I fully agree. It is the thing is the notice was a bit too short for me, and the only diagram I had already in my training course material was not translated yet in English. So I will take time to do it today. So for tomorrow we'll have a updated diagram in English. That's why I didn't want to put them in French to not penalize not French-speaking attendees today.
okay, thank you very much.
Mm.
That's
You're
just an
welcome.
observation. So any other
Okay.
questions or observation? No. Question, observation. Okay, none for now.
Well, okay, cool. Um, what would be good, I think, maybe now maybe everyone is a bit more comfortable. I would appreciate that at least for at the latest today in the evening, that we could have a list of things that you would like to emphasize that we've seen today or that we did not already saw. A part of what I already know. That or some points that you would like me to illustrate particularly. If you see something in particular, because for me, I noticed if I check my notes, I had virtualization, automation, storage, and networking. Is there anything else you would like us to go in detail with diagram tomorrow?
Do we get him? Out of those things they mentioned, is there any place, any of them that you want him to emphasize more, to go deep, instead of just discussing or paraphrasing? That you want him to go deeper? Any of this technology you want him to? Okay.
Okay.
No,
So
hold on.
I will.
Hello? Someone wants to.
Hmm?
Um, Thank you very much. I think I need more diagram on data center and server.
Okay. Okay, no
Data
problem.
servers and server. Thank you.
Okay. Okay, I will prepare that for tomorrow. Okay. DC and servers, huh? Okay.
Uh, okay.
Fine.
Uh,
Yeah. Actually, yeah. Sorry. Go
can
ahead.
I? Yeah. I was mainly about the part of storage. Maybe for the red, we don't have a clear aspect of how it works because you see it,
Sure.
but we don't have images. Maybe if you have
Okay.
images, maybe that will fix it.
Much more easy. Yeah, I fully agree with you. I realized that actually I didn't want to enter so much in detail. I wanted to wait for tomorrow for to to have the diagram translated to give you a better explanation, but I fully agree. It's not a concept. It's not complicated, but if just by speaking, it's a bit hard to realize. I fully agree with that. Mm. Okay, no problem. It will be taken in account for tomorrow. So and well, I apologize for the lack of diagram for today, but the notice was definitely very short for me. I'm I'm still I'm only 2 days detached for that. Normally I should have made the whole session, but what it was not possible because of a project we are still delivering currently. So it's already 46. I think. Hmm?
Okay. I have a question about fiber channel and ISCS. According to
Excuse you.
yes,
Excuse you.
yes,
Hmm.
you said that we have two protocols we can use to storage access storage area network,
Hmm.
and you exhort us to use ISCSS.
Excuse you.
SCI, yes.
Excuse you.
Excuse.
Excuse. Excuse
And
you.
yes,
Hmm.
excuse you. Okay. I want to know on basis on what you advise us to use this because it is more secure or performance or easy to use. Why you advise us to use
Uh,
excuse?
oh, okay. All right. Compared to just as a matter of for different reasons. I mean, in the past, I would not have recommended HPC until I saw. I think it was EcoLogic was the manufacturer which has been bought by Dell since was we'll say 10 years ago, and I must admit this reconciliated me with HPC, which I had not been really impressed in the past, and a bit discouraged by the complexity of the implementation and some others consideration related to stability, which are not anymore. Um, so to give you the basic, IceQZ is very basically SCSI frames encapsulated in IP packets. Okay, so it means that you can have a SAN infrastructure for the cost of an Ethernet infrastructure, which is not exactly the same. You see what I mean? Today, especially today in 2021, 10 gig or 25 gigs just cost nothing compared to what it was costing 10 years ago. And today, if you want 10 gig in fiber channel, I think you will confirm the price. See what I mean?
Yes, but I want to know what about the performance between the two
Oh,
protocols?
performance is yeah. I'm talking about performance. I'm talking about bit rates. So you can have I mean if it depends what you are calling. I don't think you are talking about intrinsical performance, but uh, do you mean that you want to compare a 10 gig link in a fiber channel versus 10 gig link in IceQZ? I don't think so. If you want to compare a fiber channel and IceQZ performances, I would say they are equivalent. And globally speaking, including the TCO, the total cost of owning, it's clearly in favor of IceQZ. Clearly. FC cost a lot.
Please,
Everything related to FC cost a lot.
please, what is TCO?
Oh, sorry, TCO, I explained it. I realized maybe I did not speak loud enough. TCO is total cost of ownership. I put in TCO cost of buying cost and owning cost. So applying licenses and uh, re- having a cost of resources used to manage fiber channel switches. If you don't have internally, this is a cost. When it comes to SAN, generally SAN is not something cheap.
Okay, okay.
See what I mean? It's
Yes.
another, yeah. And you will want to use SAN when you will need to have access such as block access. So I mean a virtually locally attached device simultaneously on different machines. Let me give you an example. Okay, let's consider we didn't saw yet virtualization, but we'll try to assume that all of us are a bit more familiar. Or let me see. We can take another example, but well, okay. Well, let's take a simpler example. Um, we we want to provide a load balancing between three servers. Okay, we have three servers that are serving the same resources. They can be 5 servers, for instance, or they can be let's say 5 servers. That's fine. Okay, so as we don't want to make vertical scaling, I mean we don't want to put more RAM, more disk, more CPU, blah 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 on a given machine because it's not possible or it's not interesting. We want to scale using a new machine to scale horizontally versus scaling vertically. So you will use 3 machines, for example, that will balance the load and that will be accessed using a VIP. I don't know if all of you are familiar with VIP. So probably network guys will be familiar with VIP. Let me introduce VIP is a virtual IP. It's a virtual IP address, which is not really attached to a network card, but is balanced between members. This is basic technique of load balancing. Okay, so you are load balancing in the input, which means that you are balancing a connection entering to your server between 3 servers and making them appear as one. A bit like if what you do in RAID, right? If you are using RAID 1 or RAID 0, you will see one drive, one logical drive, and behind you have several drives, okay? On a VIP, it's the same. Load balancer, you have one IP address that point actually to X servers behind the hood. Okay, so that's brilliant. But we need that those servers can serve the resources at the same time. You know, each server must serve exactly the same thing that its brothers, right?
Yes.
If we do not, we will be unsynchronized, and our client won't be happy because he won't have fresh data. Or if we can synchronize and the sync is not okay, so you don't have a lot of choice when it comes to that. You either, if you are the cheap solution is NFS, CIFS, so NAS. So we said it cheap because it doesn't involve a lot of things, a lot of knowledge, a lot of hardware to achieve. But you have performances. You have not the same performances. You have a file network, file system access, which is not exactly the same in terms of performance and in terms of things you can achieve than accessing directly a block device. By using a SAN, you can expose those disks as if they were local disks. You see the difference? In one case, you will mount a share, and in another case, you will write on a block device, which is not the same. As if it was a locally attached disk.
You need to synchronize.
You don't you don't have no more synchronization. Okay, I will make a draw tomorrow. Okay, if to explain that. No, yeah, there is synchronization if you have nothing. It's the worst solution. You don't want that. This is shit. Unless
Okay.
some particular cases. But the first solution is have a common storage at the end. You forgot about synchronization. You have a common storage, and the two ways to have a common storage is either NFS or either let's say either NAS or either SAN. NAS will be quick. You will have create a share. You can do that even on Windows, or Linux also can create a Windows share using SM-based CIFS or using NFS, the good old NFS, which is widely used for that. And it's a quick and cheap answer to this need to the mutualized storage. Okay, SAN is an higher level uh, solution for that, and it provides you with a block access. So it's as if you have a virtual hard disk that would be simultaneously plugged on each machine. You see the difference? I, I, I describe you. It will be crystal clear for you. I promise you tomorrow
Okay, okay.
with diagram. Because I realized it's not that easy to explaining without a diagram. I think it's as simple as ready. So I will take this opportunity also to illustrate the VIP. So no problem for that. It's on my agenda for today.
Sir, I have a last question.
Yeah, sure. Go
But
ahead.
okay, but I will speak French, please. Excuse me. Bon, j'ai remarqué que la fibre, fibre channel est au niveau de la couche 2 et Squeezie est au niveau de la couche 3. Donc j'aimerais savoir si le fait d'être sur la couche 3 impacte sur le fonctionnement de Squeezie.
Oui, il y a un très léger impact. Il y a un très léger impact en termes de performance. Okay, let me resume. Our colleague asked that fiber channel is working on layer 2 instead of IceQZ, which is working indeed on at least on layer 3, which is the UPL layer on network layers, and rather than on MAC layer. And the question was, does it impact performance? I mean, intrinsically, indeed, layer 2 will be slightly more efficient, slightly, but this can be well compensated by using an adapted, what we call an offload, TCP offload adapter. And TCP offload is a bit like, if you remember what we said with RAID, with hardware versus software RAID. There is a bit the same when it comes to network card. So a modern network card, especially the one which are using the Intel Pro Mill or Intel Pro 1000 or equivalent all this, well, I mean, almost all server-grade network cards are offloading TCP, or using TCP offload. This is the feature name. And TCP offload is offloading main CPU of all TCP checksum calculations and other integrity checks. That would be the only overhead from my point of view that could adversely affect ISQZ performances. So to answer your question, I would say that theoretically yes, but practically no. ISQZ becomes more and more competitive. Really, it's my personal recommendation. The main reason, the big reason for that is the media price and the switch price and the performance you can achieve if you want an equivalent using fiber channel. The cost will be incredible.
Okay, thank you, sir.
But as every medal, it has a drawback. It means that I mean, if you want to do it by yourself, it's really a good option. When TrueNAS and FreeNAS are handling that, they can create they can handle ISQs nicely. But it will go with following a few recommendations. It's still a bit of work. It's all depend of which kind of public you are. If you have an unlimited budget and you don't care, okay, go for FC. And go for an all-in-one appliance that you won't have to. But even with an all-in-one appliance, you will get in trouble if you don't spend the time to understand how it works. So even with unlimited budget, I would not say okay, go for a proprietary solution. Moreover, I would say that well, this is more for network, but it comes also for storage. But it's more and more. I would say it's more and more clear on network. If, for instance, I'm originally a Cisco guy, you know. I used to know Extreme Network, Juniper, Cisco, Aruba, and a few of them, even Matra, Alcatel. I saw a lot of manufacturers, and indeed, all of them had an added value on some aspect. But a few years ago, there has been big changes, some big changes appearing in the network world. I mean, disruptive changes linked to the virtualization. I mean that this applied to a lot of aspect of network, not only on the LAN or one or every aspect of network has been concerned by that, which is we tend to move the intelligence from the switch to the soft. So more and more, as long the more it goes, the more we remove the intelligence from the switch, and we use a very basic switch with a limited feature only for collection, for traffic collection, and the intelligence is run on soft. So the switch is just here to aggregate, and all the added value feature that was costing a lot on the switch. If you want an L3 switch, it's not the same cost that an L2 switch. And an L2 switch is not the same cost if it's manageable or not. You see? And the big revolution I could assist was a few years ago when some manufacturer decided to go for what they call the ONI initiative, which the idea is to sell you just the hardware, just the silicon. So you buy an empty switch. You buy a switch with just a bootstrap on it, and you choose whatever you want to run on it. This is brilliant. And this is what NVIDIA is doing. Well, it's about Mellanox, and Mellanox is doing that with their last switch product line, and a lot of manufacturers are following them, which means that you have not the question of to know, okay, do I know the operating system or not? So this is something we can discuss maybe tomorrow also. But this is definitely a consideration. Things are really changing, and the game is changing, especially for network and storage this last year. Yeah. We go for standards. Okay, guys, I think it's time for you. If you have no any special questions, I think we can say it's over for today.
Is done. Okay. Thank you very much. I think in the absence of any question, we can call it a day. So we
All
want
right.
to appreciate you for the time and
Thank
for
you.
the impacts of the knowledge. Thank you very
All right.
much. Tomorrow we are starting 9 a.m. local time.
Okay, 9 a.m. Okay, so it will be 10 for me. All
Yeah.
right. Fine for me, and I will prepare. So don't worry, I will prepare the translated diagram. It will be much more digest this way.
Okay. Thank you very
All
much.
right. You're
So
welcome, guys,
have a
and
wonderful
ladies
night.
and gentlemen. Have a very nice day, and thanks for your participation. See you tomorrow. Then.
Thank you. Bye bye.
Cheers. Bye.
So thank you for your time. We can call it a day. And please, tomorrow, let's ensure that we quickly take our